Question number 18 is the last question. Here I have to find the value of p and the function is continuous. See, at 0 plus I'll take this function, at 0 also I will take this function. But at 0 minus I will take this function. 0 less than 0. On the left side of 0 and on the right side of 0. This is the left side of 0. So already it is limit x tending to 0, fx is equal to 0 because this is continuous. I'll use limit x tending to 0 plus fx is equal to limit x tending to 0 minus fx is equal to f of 0. Now I'll take this minus and this one only, not this one, because at at 0 plus, at 0 plus, sorry, at 0 plus and at 0 plus I'll have to take this function, and at 0, because this is an equal to sign, I'll have to take this function. So no, there is no use doing this. So I'll take 0 minus left hand limit and the function value at 0. देखो, ये 0 माइनस में ये वाला है और इस 0 प्लस में भी ये फंक्शन है और 0 में भी ये फंक्शन है, क्योंकि इक्वल टू का साइन यहाँ पे लगा हुआ है। तो इस फंक्शन को 0 प्लस लेना और इसको लेना कोई फायदा नहीं है। तो सिर्फ लोगे लिमिट एक्सटेंडिंग टू 0 माइनस और f0 को लोगे, दैट्स इट। सो यू विल टेक ओनली f0 and f0 minus, that is the left hand side. There is no use taking the right hand, because at right hand also you have to take this function, and at 0 also you take the function, it will give you the same value. So no use. Now let's do it. Let's rub all this. Let's now do it. Now this is, wait a minute. Yes, limit x tending to 0 minus 1 plus px to the power of half, 1 plus px to the power of half minus 1 minus px to the power of half upon x is equal to, what is f0? What is f0? So let's find f0. f0 is this function, 2 into 0 plus 1 upon 0 minus 1. So this will give me 1 upon minus 1. Our answer would be minus 1. So the answer would be minus 1. So let's write it straight, minus 1. This is equal to minus 1. Minus 1. So this is equal to minus 1. Now expand by binomial. So limit x tending to 0 minus, the expand by binomial, 1 plus p half px plus half minus 1, half minus, wait a minute, this will be half minus 1 upon 2 factorial is 2 p square x square plus, and then it will be plus half minus 1, half minus 2 upon 3 factorial, this is nothing but 6 p cube x cube, and so on and so forth. This will carry on. Minus, see, minus, let's write it this way. Yes, minus this one now, half minus half px plus, because it goes alternatively, ये alternatively चलता है, half minus 1 upon 2 factorial p square x square minus, let's go this way. Let me take more area. Yes, minus, let's write it properly. This is p square x square, then minus half minus 1, half minus 2, 3 factorial, that is 6 p cube x cube, and so on and so forth, upon the whole of x, and this is equal to minus 1. Now you will see one thing. If you look at this अगर इसको देखोगे तो देखो, this one will cancel out with this one. This is plus and this is minus and this is minus. So this will become plus. This even terms will all cancel out. Odd terms will add up. So odd terms, देखो 1 कट जाएगा, ये हाफ पी एक्स है, यहाँ पे माइनस हाफ है, और यहाँ पे माइनस है, यहाँ पे माइनस है, तो प्लस हाफ पी एक्स एंड प्लस हाफ पी एक्स हो जाएगा. And this is this quantity and this quantity will cancel out. Similarly, this quantity, and wait a minute, Let me drag it. This quantity. This quantity will again add up because this is p cube x cube. Let me write it clearly. Wait. P cube x cube it is. P cube x cube and so on and so forth. And this is equal to minus 1. So all the odd powers will remain. All odd powers will remain. All even powers will go. So let's see what happens. Let us now write again. See, before I start the intermediate value theorem, I'll do this. Then I'll start the intermediate value theorem. Wait. Then this is limit x tending to 0. What you are now left with minus half px, and half px is px. Then you have plus 2 times half minus 1, half then half here. Wait a minute. Let's write the third term. That is this term 2 times. This term 2 times. So let's rub it here. 2 into half minus 1, half minus 2 upon 6 p cube x cube and so on and so forth upon x, and this is equal to minus 1. Now cancel this x with this. This will become 2x square and take the limit. So what all these higher terms will be 0. देखो ये x इसके साथ कट जाएगा, ये x square बन जाएगा, कट के this was 3 here, this will cut and this will become x square. This x square it will become, and then you take the limit. उसका limit ले लो तो जितने भी x और higher order terms है सारे क्या हो जाएंगे 0. All the x and the higher order terms of x will become 0. So you are left with p, and then you have minus 1. P has a value minus 1. I hope you have understood this. Now we will start something called very, very important, and that is the intermediate value theorem. Let us understand this. Let us understand it. The intermediate value theorem. Wait a minute. Yes. This we need to understand. The intermediate value theorem. It states that if function is continuous, then if the function is continuous on an interval a b, then if attains each value between a b at least once. Let me write down the this, and then we will. If fx is continuous on closed interval a b, then fx attains each of its value each of its value its each of the values value between fa and fb once. That means once. That means suppose this is a function from AB, it will go to FA to FB, because closed intervals are mapped to closed intervals. I told you earlier, closed and bounded intervals. This is closed and bounded, so the image will be closed and bounded. The range will be closed and bounded, I mean to say. So every value it will take at least once between AB. That means if I say that this way, if I say it in this way, if I try to tell it in this manner, that is, if I say it in this manner, let us try to understand it in a different manner. Suppose you have this interval. Let us now understand. This is the interval AB. This is the interval AB. We are understanding this. Now, there is a value, suppose any value k belonging to R, the real number, such that if A is less than k and this FB, then there exists a C belonging to this interval AB such that FC is K. मतलब कहने का मतलब ये है, ये मेरा ग्राफ है, this is my graph, this is my x-axis, this is my y-axis, this is my function, whatever is going. So this is the point A, this is the point B. For here it is FA, and for here it is the point FB. This is FB, So if the point K is somewhere is here, somewhere on this line, suppose K is on this line, on this line, K say is somewhere here, then there is a point corresponding to K, this point C, such that K is equal to FC. कहने का मतलब ये है कि एक पॉइंट ए है और दूसरा पॉइंट बी है। ए के लिए एफ ए है, बी के लिए एफ बी है। अगर इस कर्व में कोई पॉइंट मुझे मिल जाए के, जो कहाँ पे बिलोंग कर रहा है, रियल लाइन पे बिलोंग करेगा, रियल नंबर पे, सॉरी रियल नंबर पे बिलोंग करेगा, तो उस के कॉरस्पॉन्डिंग एक सी मुझे मिलेगा जहां पे के इज इक्वल टू एफ सी। इसका मतलब ये होता है, दिस इज व्हाट इट मीन्स बाय इंटरमीडिएट वैल्यू थ्योरम। नाउ वन मोर इंपॉर्टेंट थिंग, continuous is, and this is called, and this property is called IVP. This property is the IVP, initial value property. Now let us understand one important line in this, one very important point, and then we'll discuss this further. That if then we are saying then it attains, then if this, then the whole of this, that means this the remaining part is the intermediate value property. Now that means one thing, continuous continuity 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 implies IVP, continuity implies IVP। और कंटिन्यूअस है तो IVP जरूर होगा, अगर नॉट IVP then not continuous shortcut। And one more, not continuous, if I say not continuous, shortcut में लिख रहा हूँ, CTS means I write CTS in shortcut as continuous। Not continuous does not mean does not mean, let us write it in mathematical sense, does not mean not IVP। मतलब means if a function is not continuous, still it may have IVP। A function which is continuous always has IVP. Not IVP means not continuous, but does not mean that continuous. If it's not continuous, it does not mean it is not IVP. The function may not be continuous, but it may still be IVP. This means sorry, not continuous still may be IVP. That it means. That what it means. That what it means. See, this is sufficient to consider this, but this is necessary. This part is necessary and this is sufficient. Let us understand with a common example. Raining. Let's change the color. Wait. Let's take some other color. Yes. Raining implies cloudy. तो रेनिंग बोल देने से, इफ आई से इट्स रेनिंग, आई डो नॉट हैव टू से इट इज क्लाउडी। अगर मैं रेनिंग बोल दूं तो क्लाउडी अलग से बोलने की जरूरत नहीं है। रेनिंग हो रहा है तो मतलब क्लाउडी तो जरूर है, तो क्लाउड होना नेसेसरी है रेन के लिए, और रेनिंग बोलना सफिशियंट है क्लाउडी बोलने का, अलग से क्लाउडी बोलने की जरूरत नहीं है। अगर इफ आई से इट्स रेनिंग, मुझे अलग से क्लाउडी बोलने की जरूरत नहीं है। इफ आई से इट्स रेनिंग, इट्स नॉट, आई डो नॉट हैव टू से दैट इट इज क्लाउडी। Raining will automatically imply cloudy, but cloud is necessary for raining. Therefore, this is the necessary condition, and this is the sufficient condition. This is necessary. This is necessary. This is the necessary thing, and this is the sufficient thing. Sufficient one. This is the sufficient one. So suppose if I say it's raining, I do not need to tell it's cloudy, and but yes, cloud is necessary for raining. But if I say it's cloudy, it does not mean it is raining. Not cloudy implies not raining. Without cloud, you cannot have rain. Not cloudy means not. See, I'll try to make you understand this with this idea. Raining implies cloudy. Not cloudy implies not raining. Not raining does not imply it is not cloudy. Agar if it's not raining, it does not mean it's cloudy. It can be still be cloudy. That's what I mean. I hope you have understood this concept here. Now let us understand with the example. Continuity implies IVP and all this. Let us first prove this. FC equal to K, this above part. I mean to say this part. Wait. I'm talking about this part. Wait a minute. Let me show you this part. Sorry. This part. I want to show you this proof. If this thing has, then this proof I need to show you. Now let us take in this manner. Without the any this, let us take, see, one very thing, important thing is here. Sorry. Now let us change the color and let's do the proof of this. Now I suppose that FA is less than FB. You may suppose FB is less than FA, that is your choice. And let K belong to R such that FA is less than K, less than FB. Define a function gx. So before I define a function, let me tell you one thing. Let me tell you, consider this much part. What will you get? FA less than K. That means FA, bring this K here, minus K is less than 0. Now this term, now you consider these two. Now K is less than FB. That means if you bring K here, 0 is greater than FB minus C. So this quantity, let us consider this quantity as a part of some function, say gx. Gx is equal to fx minus k. Now at the point ga, इस फंक्शन को, इसको एक फंक्शन मान लो ga. ये देखो, ये वाला पार्ट बड़ा है, सॉरी दिस इज k नॉट c, by mistake I wrote it k, it is k. This part is greater and this part is smaller than 0. This is positive quantity, this is negative quantity. So let us consider this as fx minus k. Now at, let's take it down. Let me take some page. Now at a, if you take g at x equal to a, you will get fa minus k, and this quantity is less than 0. Now take this quantity, gb is equal to fb minus k, and this quantity is greater than 0. If you see the graph of x-axis and g, and this is the point a and this is the point b, at fa, so let me draw the graph a little other way around. Wait a minute, I'll show you the graph. Wait a minute, let me draw it in this manner. Let me draw it in this manner. This is your x-axis, this is your y-axis, this is your point A, and this is your point B. At this is the graph of G. Now GA is smaller than 0, so less than 0, so G will be somewhere here. GA would be somewhere here. GA would be somewhere here. It will cross the graph and go up. This will be GB because GB is greater than 0. देखो GA less than 0 है, तो वो कहीं यहाँ होगा, x-axis के नीचे. Since GA is less than 0, it is below the x-axis. And GB is greater than 0, it is above the x-axis, so it is positive. It will cut the x-axis at least one point, say C. It will cut it at C. That means GC is 0. Now at C you put this. At x equal to C you put this. So what do you get? At GC what do you get? FC minus K equal to 0 implies FC equal to K. So proved. This is proved. So the point that is here is that GA, see, GA quantity is less than 0, so it is below the x-axis. GA less than 0 है, इसलिए x-axis के नीचे है, negative पे है. GB is positive, so GB is above the x-axis. वो x-axis के ऊपर है. तो कोई भी ग्राफ अगर ऊपर से नीचे जाएगा, एक बार तो x-axis को काटेगा. यहाँ ये point क्या होता है? Once the graph goes from the negative to the positive side, it will cut the x-axis at least at this point. It will cut the x-axis here, it will cut the x-axis here. At this point, the g value is what? 0. That's what I have written here, g value 0. This, and what is gc? Put here c, put here c, put here c. The fc minus fk is 0. Therefore, fc is equal to k. That's what I have to prove. Now I will show you certain examples. Wait. I'll show you certain examples that will help you understand this concept better. Now, take one example, this. Take an example of, see, you take the first example, number 1 example. You take fx equal to sin x. Sin x is a continuous function, you know it. And let us say f is defined from minus pi to pi up to r. It is going from, that is, you are talking about this part, 0, pi by 2, and minus pi, and you are talking here minus pi by 2 to pi. So it can take any value in R, no problem. So this is your line y equal to 1, and this is your line y equal to 0. This is your y-axis, this is your x-axis. Basically, this is y equal to 0 line. Now you know the graph of this goes like this. The graph of this goes like this. So this is continuous, and it takes every value between these numbers. It takes every value. So continuous implies IVP. Done. Example done. Next one, if you take the next one, in which I will show you not IVP implies not continuous. This is a bit tricky example. Just see it very carefully. Now I define the question as number 2 example. Here I take f from 0 to 1 to r up to r, and I define the function like this: fx equal to x for x belonging to 0 1, and is equal to 1 for x equal to 0, and equal to 0 at x equal to 1. मतलब 0 और 1 के बीच में जो भी वैल्यू होगा x का, it will be the same value. At 0 it will be 1, at 1 it will be 0. When you put that, means I mean to say that means f at 1, f at 0 it will be 1, f at 0 at 1 it will be 0. Wait a minute. F at 1 it will be 0, f at 1 it will be 0, and f of x will be equal to x for all x between 1 and greater than 0. This is what I mean. This इसका मतलब ये होता है कि अगर x 0 है तो फंक्शन की वैल्यू 1 है, जो यहाँ पे है. अगर 1 है तो फंक्शन की वैल्यू 0 है, और उसके बीच में है, 0 और 1 के बीच में है, तो जो भी वैल्यू होगा, हाफ है तो हाफ आ जाएगा, और 3/4 है तो 3/4 आ जाएगा. दिस इज द वे. नाउ यू सी वन थिंग. Now you see one thing. If you take a value, say f of half, half lies here, so it will be half only. F of half you take is less than, half will give me half. You know half is less than 3 by 4, less than 1, isn't it or not? This is the thing. So f of half, and let us take 3 by 4, and let us take it f of this is as 1, which is basically f of 0. This is basically f of 0, right? So between 0 and half, between this point is 0, this point is half. That means this point is 0 and half. So this is the value k. This is, let's say, this is your this is behaving like this is f of a, some sort of, you can write any way you feel like. This is f of b. So your a is actually 0, and your b is actually half. So the interval is 0 to, your interval is 0 to half, right? But now you won't find a c. What I said, this is possible, na? F half is half. Well, make you understand again. See, now this a is 0, this much you have understood. Now come from here, f half is how much? Half. This is 3 by 4, this is 1. So this is behaving like k, this is behaving like f of b, this is behaving like f of 0. So this way the inequality, this is the way it is. But yes, of course, but you don't confuse that a and b are arbitrary. I can take it this way. Now this is a is 0 and b is half, so it's between 0 and half. Now the point is, I won't find a point c. There does not exist c between 0 and half such that f of c is equal to this k, and k is what? Here 3 by 4. I will not find, because 3 by 4 is after this, and 3 by 4 does not lie here. ध्यान से देखो. Now this is f0 is 1, f1 0, fx is x for x between 0 and 1. I have taken this way. I have taken this way. You say this half. I've taken 3 by 4 and 1. I've taken this much. This is behaving like, wait, let me rub this. Let me rub this. Yes. This half is what? This half is not, f half is half. This is here. 3 by 4 is 3 by 4. This is for f0. Now this is somewhat can be compared like this. Now this is your fb, k and f0. A is 0 and B is half. So between the interval is 0 and half. But there does not exist a C between 0 and half such that FC is 0, because 3 by 4, because anything between 0 and 1, see this, anything between, anything between 0 and 1, anything between 0 and 1 will have the same value. 3 by 4 should give me 3 by 4. But here 3 by 4 should give me 3 by 4, because 3 by 4 is between 0 and 1. But here in this interval, I will not get any C in this interval. That will give me 3 by 4, but still 3 by 4. So it is not IVP and hence not continuous. At where? It is not continuous at 0, it is not continuous at 1. This function is not continuous at 0 and not at 1. So not IVP implies not continuous. This is proved. This idea is clear. Next one, if I take third is not continuous, but still IVP, intermediate value property is still satisfied. This is the point. Intermediate value is still satisfied. So if I take this one, let me take f from minus 2 by pi to 2 by pi to r. Now fx fx is defined as sine 1 upon x, for x not equal to 0 and is equal to 0 for x equal to 0. So this takes every value between, now you see, this will take, because sine 1 upon x is somewhat like this, looks like this type. So I have already told you earlier, limit x tending to 0 plus sine 1 upon x is plus 1, and limit x tending to 0 minus sine 1 upon x is minus 1. The limit is not there, so it is not continuous. But it takes all values between minus this 2 by pi to this is C. Now, if you take a value not 0, which is not 0, if you take a value which is not 0, wait a minute, yes, which is not 0, let's take this and the last value, because this is not continuous. So now you take f minus 2 by pi. So you will write sine 1 upon minus 2 by pi. This will be sine minus pi by 2. This is minus sine pi by 2, and it will be minus 1. And you take 2 by pi. Similarly, you will write sine 1 divided by 2 by pi, which is equal to sine pi by 2. So this is sine, this is nothing but 1. So it takes all values between 1 and minus 1, but it is still not continuous.